Welcome to the Ultralight Airplane Workshop. My name is Leon. I'm very excited to be making this video because I've finally had success with vacuum resin infusion on my carbon fiber samples. Let me give you a little bit of background on what I am trying to accomplish with these carbon fiber resin infusion samples. I like the freedom in aerodynamic form that I can get with composites. In other words, complex curvatures that are much more difficult to get in metal or in fabric-covered wood or tube. In addition, I wanted to do some electric propulsion on an ultralight, and in order to get a long endurance for flight time, I wanted to have a fairly clean aerodynamic form on the ultralight. And using composites is much easier to get that clean aerodynamic form than with most other building materials. Before I got too far into the project, I wanted to assure myself that I should be able to at least make the weight limit from the FAA Part 103 restriction of 254 pounds empty weight. Well, I decided one of the easiest ways to do that, and there are probably several ways to do it, but one of the easiest ways to do it would be to try to compare sheets of composite against sheets of aluminum. And the reason I thought of that is because I'm fairly familiar with the Hummel Ultra Cruiser. That's a fairly clean design, which is what I'm going toward, trying to get a clean design for long flight duration with electric power. And I thought if I can come up with some composite sheets that perform at least as good as aluminum sheets that were used to cover the Ultra Cruiser, I should be able to come up with an ultralight that meets the Part 103 weight requirements. The Ultra Cruiser uses 16 thousandths thick 6061 T6 aluminum sheet for the wings, for the fuselage, for the tails, and that's a significant portion of the weight of that airplane. So if I can come up with some carbon fiber sheets or similar composite sheets that at least performs as well as that 6061 16 thousandths thick aluminum, I'm home free. That's what I've been doing for the last few months, is trying to come up with some carbon fiber sheets that I can then test to compare it to a sheet of aluminum and see if they're comparable or superior. Now, I could use some hand layup with vacuum bagging, and that's certainly a possibility. I imagine some parts will be made using that method. But I should be able to get more consistent parts, more reliable parts, if I used resin infusion. So I've mostly been geared toward trying to get resin infusion to work. Well, an easy comparison between the carbon fiber and the aluminum sheet would be weight and stiffness. What I did then to do comparisons is I cut a sheet of aluminum of 6061 T6, 16 thousandths thick. I cut it to 12 inches by 12 inches, which is roughly 30 centimeters by 30 centimeters. And I weighed it out, and it turned out to be 101 grams. And of course, I can do some stiffness tests on this just by putting it on the edge of a table, put a little weight on it, measure how far it deflects, and then I'll make carbon fiber samples, do that same measurement. If I can get carbon fiber that's stiffer and lighter, or at least equivalent, then I could build an ultralight, possibly. Then I'll proceed on to the next testing, which would be the shear testing. So I started making my carbon fiber test samples with vacuum resin infusion. I want to use vacuum resin infusion because if I get it done right, it would be lighter than doing a wet layup, and it should be more consistent, less issues with delamination due to bubbles between the layers. Now, my early samples really dealt with dealing with pinhole leaks in the vacuum bag. I had a vacuum bag material that was seconds, which means it wasn't the best vacuum bag material, and I found out why. It had lots of pinholes. So a lot of these fails were due to pinholes and trying to learn how to deal with those. But as you can see on this sample that I took, which was a very early one, I wrote down what happened with my sample. So this is a 2-ply, 2-twill, 3K toe, with 13 toes per inch, and the orientation is 0 to 90. So on these sides, 0 degrees, 90 degrees are how the toes are organized. The epoxy I used was epoxy, and I used the resin of 2032, the hardener of 3663. I did a room temperature cure, 71 degrees Fahrenheit, and this was back in December, and then I weighed it. Now this was a failure due to pinholes. And then I did another test trying to work with pinholes. I didn't write the date on this, but it was pretty close to the date of the other one. Same kind of information. I weighed it. I also took thickness measurements on these. Now these thicknesses were around 20 thousandths, so about half a millimeter. So that's a little over the thickness of my aluminum, but that's not really important. It's the weight and stiffness that's really important. This happened to be a test I wanted to keep around. As you can see over here in this corner, I had a pretty bad air leak over here. In fact, I think this was a video that I took doing some videoing from underneath to see what it looked like, looking through some acrylic. This is also a fail for another reason. I somehow screwed up doing my calculation on the resin and only got half the hardener in that I should have, and I realized that while I was degassing. So I said, well, you know what? Let's go ahead and finish running this test. And what I will do in the future is I will do a shear test and compare how only having half your hardener affects the outcome. So it'll be an interesting test in the future when we do some destructive testing on these samples. Another thing that I tried on this, which was really pointless at this point, is I put a heating pad on this. I heated this up to 120 degrees Fahrenheit temperature. Now here's where I started getting serious about trying to figure out why I wasn't getting a good surface finish. Because I had noticed on all these samples over here, I was not getting a good surface finish. Let me show you a photo here of what the surface finish looks like. And as you can see in this photo, I'm not getting the crimps filled on the mold side of my sample. So this was my first test of trying to figure out why that is. And what I did on this test is I turned up my room temperature to 80 degrees Fahrenheit. I had been around 72 degrees. When you increase the temperature of your resin, it gets a little bit thinner. The viscosity drops, which means it flows a little bit easier. I thought maybe it's just not flowing down through my carbon fiber sample down to that mold surface just because it's too thick. So this was a test to get it up to 80 degrees Fahrenheit. And in addition, I had a heat pad and ran that at 130 degrees after the initial infusion. One, to help it speed up a little bit in curing, and to see if that would help with maybe flowing down in there to the mold surface. That did not work either. But other than that, I like the finish. It's nice and shiny. But I still have issues with the crimps getting filled in. Well, at this point, I decided I've got to start mixing things up, changing things one at a time, doing a test, see if I got a good infusion. If not, change one more thing. I started thinking of things that could possibly be wrong, and of course I was getting some good comments on these videos, giving me suggestions on things to try. Now I had been using an epoxy that wasn't really designed to do resin infusion, although if you look at the hardener, which was the Aero Epoxy pH 3663, they describe it as a structural infusion, and basically because that hardener is so thin that it thins it down enough you could use it for infusion. But I thought, well, maybe that's the problem. Let's try a different epoxy. So I switched over to a Proset epoxy, which is the INF 114 and IFP 211. That's a medium cure length epoxy that's designed for resin infusion. So I thought I'd give that a try. And also for all these tests up to this point, I have been using the Free Coat 700 NC release agent on my mold surface. And this one was also cured at room temperature of 80 degrees Fahrenheit. And again, it failed. Not quite as bad. Some of the crimps would fill and some wouldn't. So the change in viscosity, by the way, the Proset was a slightly lower viscosity than the Aero Epoxy. It's just slightly better, but only slightly, not good enough. Well, the next one was kind of an interesting test. Well, maybe there's just something wrong with my Free Coat release agent. Well, I've got some PVA. Let's give that a try. So I've prepared my mold surface with PVA, and we gave that a shot. This is still using the Proset and 130 degree cure temperature. And of course, PVA always gives you a rough surface finish, so I expected that. But it also did not fill the crimps. So I decided that probably wasn't the issue. So change something else, try again. So I thought, well, maybe it's the kind of fabric that I'm using. So I have a different kind of fabric. This is a biaxial fabric, and it's at 45 degrees bias. It's a little bit thinner. And I went back to a room temperature, and I kept the Proset the same, and I'm also still using my 700 NC free coat release agent. And on that one, again, it did not fill. There's not really crimps in this, but there are small gaps where these fibers are woven together. And that did not work. Another suggestion I had in comments was I wasn't using enough vacuum. The vacuum pump I had been using could only pull 25.5 inches of mercury of vacuum. So I broke down and I got a vacuum that could pull 28.5. And so I did a test with that. And again, it did not fill the crimps, although it came much closer. There were small areas where the crimps were filled. So it helped, but it wasn't sufficient, but it was very, very close. So next thing I thought, well, that's getting us closer. Let's try another change with my release agent. Part of that was instigated by the fact that my 700 NC free coat was 7 months old, and that's roughly the shelf life of it. I thought, well, I need some new release agent anyway. Let's buy some new release agent and see what happens with that. So I got the Extend 900 SAM release agent. It's a chemical release agent, but almost the same exact result that I got previously with the free coat. So that really wasn't a help, but it came close. They're just small areas where it's very close to filling the crimps. Let me talk a little bit about the layer stack that I have been using. As I mentioned before, I've been using 2-ply of the carbon fiber, and I don't think I mentioned about it's 200 grams per square meter weight on that fiber, so it's pretty thin. And once you get it cured, it's around 20 mils thick, so about 0.5 millimeter. On top of those 2 layers of carbon fiber, I put a layer of peel ply, and then on top of that, I put a layer of flow media. Everything I had seen up to that point said you need flow media to help that epoxy flow through when you're pulling the vacuum and pulling the resin through the sample. The flow media I have been using was this blue mesh, very large squares on it, openings, and it's a little over 1 millimeter thick, so about 44 thousandths, roughly in that area. And I had a comment that said, you know what, you don't need flow media and you don't even need peel ply. So I thought, well, let's give it a try. So I did a layup that only had the 2 layers of carbon fiber, peel ply, and then the vacuum bag. So there was no flow media at all. And of course I used my big vacuum pump just to make sure I had plenty of vacuum to pull through. So it flowed in from this side. It was not able to pull the resin all the way through. It only made it up to right in here. Now there's kind of 2 issues probably. One is there just wasn't enough pressure difference to make it flow through. And the other is by the time it got over here, it was starting to get a little bit thick. So I thought, well, you know what? This finish is fantastic. The area where I was able to get the resin to flow through, I had a great finish. I was very excited about that. So that was the first time I'd had a good finish on a sample. So I said, hey, we're in the ballpark. If we can just get that epoxy to flow through a little bit better, we'll get a good sample. While I was performing the vacuum infusion on this last test, and on many other previous tests, I had noticed that the epoxy likes to flow through wrinkles in the peel ply faster than when there are no wrinkles. And I thought, well, what if I intentionally put wrinkles in the peel ply running down the length in the direction that I want the resin to flow? Maybe that will help the resin get to the far end, to the vacuum end, before it starts to gel. So that was my next test. On this test, it's the same as the last one. It's just that I intentionally put those wrinkles in the peel ply. And I put 5 wrinkles in them, and you can actually see where they are on the back of this test. There was one here, one here, one here, and one here. So That resin did flow better down through where those wrinkles are. The problem is that it didn't propagate sideways enough to help fill in the weave of the cloth. But I still got a fantastic finish. The only place where it wasn't fantastic is right up here near the edge, right where it ran out of momentum to go. So I was still getting a pretty good finish on the rest of the piece, so I was very happy with that. So at this point I decided I need some kind of flow media. And I got to thinking of what I could use for flow media. I looked online, tried to find flow media that would restrict the flow a little bit more. And unfortunately, it's a little bit difficult, at least on the distributor sites, to get enough information on the flow media. And I happened to hit upon the idea of some insect screen. I happened to have some laying around, so I went and measured it. And it was 10 thousandths thick. And I thought, well, by golly, that should restrict the resin flow, but still let some go through. So that's what I did. I did another test, except this time for flow media, I put one layer of insect screen in. Just one ply. Resin came in from this side. And you can see, again, I didn't make it to the end of the vacuum side with my resin. And I intentionally removed all wrinkles from the vacuum bag when I put it in, just so I could find out what would the screen by itself do. Well, obviously it didn't work. I got roughly the same result as the previous two tests. And I thought about it, and I think what was happening is that the very small crimps in the screen were being plugged up on the vacuum side on top and on the peel ply from underneath. So I needed just a little bit larger crimps that wouldn't get plugged up. So I thought, well, you know, if we put 2 plies of screen in there, it would be very difficult to plug up openings. The resin should be able to go in between those plies, up and down between the weaves of those plies. So that was the next test. So I put 2 plies in on the next test. And I got an excellent result. In fact, I've already trimmed this one. Resin went all the way through, and I got a fantastic finish throughout the part from end to end. I at least got a method to make an excellent sample of this 2-ply 2x2 twill that's only 200 grams per square meter per ply. And I'll show a photo right here of a comparison between this part and previous parts that had failed to get the resin down to the mold surface. Well, since I was able to successfully get a part using those 2 plies of insect screen and using my full vacuum, I wanted now to go back and do a test using the same exact layup, but now use my old vacuum that would only pull 25.5 inches of mercury, and see if the extra vacuum, the 28.5, is really needed to get a successful part. So that's what this test is. So I degassed at 25.5, and then I read the infusion at 25.5. And in this case, everything else is the same, so I used the Proset epoxy, and I used the X10 release. In this case, the finish is good, but not as good. I was getting some very small pinholes. So you might be able to see there are some very small pinholes, but overall, it's still a pretty darn good finish. In a pinch, I could use that 25.5 inches of mercury pump, but I think I'll use the bigger vacuum pump from now on. So I'm really excited that I finally got a good test sample with a great finish against my mold surface. What I want to do is find some actual flow media that's thinner and will give me about the same results as this 2 layers of insect screen. If you know of any flow media that's about 2 mils thick or 0.5 millimeter, I'd be interested in knowing about it so I can give it a try. Well, now that I got some decent test samples, I'm going to move on to testing. So we'll be testing stiffness, weight, and I'm developing a little rig that we can do some shear testing. So we're going to be pulling some carbon fiber samples apart. If you're interested in seeing some destruction of carbon fiber and seeing what the results are, Make sure you subscribe to the channel and hit that little bell button. You'll be notified when those videos come up.